Good morning, good afternoon, whenever you're watching this. Here's our pre-calculus problem of the day. So we want to graph y equals 1 minus e to the x, and then we're going to state the domain range and asymptote. So should be familiar with a basic exponential function. So whatever the base is, if you just have y equals a to the x, and a could be 2 or 3 or 4, or any real number greater than 0, really, except for 1, um, including e. So e is approximately 2.71. So any exponential function, basic exponential function looks like this. And then the y-intercept, of course, is going to be 1. Domain for all of these basic exponential functions is going to be all real numbers. The range of this parent function is going to be 0 to infinity. And then we have a horizontal asymptote at y equals 0. So keeping all that in mind, and then also keeping in mind our rules for transformations that you might probably learned about in chapter 2 or 3. I think that was chapter 2. But anyway, about vertical shifts, horizontal shifts, reflecting around the x-axis, and so on. Keeping those in mind, we can graph this. So uh, we could call this the graph of y equals e to the x, because a could be any positive real number other than 1. So e fits that description. So we can start with this graph and then just kind of work your way through these transformations. So the vertical transformations always last. You want to do the other ones, the horizontals and the reflections, the stretches, anything like that before you do the vertical. So first we have this negative here. So what would it look like if we did e to the or negative e to the x? So the negative in front reflects over the x-axis. So this is just going to be an upside down exponential. And so now that would be a y-intercept of -1. So if you plug in 0 here, e to the 0 is 1. Put a negative in front of that, we get -1. So all we're doing is just reflecting this upside down. So it looks like that. Then we will shift it up. So the +1, so that's a +1, is going to shift it up. So y equals 1 minus e to the x. We're going to take this one and shift it up 1 unit. And so we'll come down. And if you like, you can think about some things. Like this one still has the horizontal asymptote at y equals 0. So we reflect it around the x-axis. So the horizontal asymptote is not going to change when you just reflect. And then the y-intercept, of course, goes around 0. So it goes from 1 to -1, which you could also manually figure that out, which we did. Now we're going to take all these. So let's write y-intercept at 0, 1, 0, -1, 0, -1. And now we're just shifting everything up. So now the horizontal asymptote is going to be at y equals 1. So we're at y equals 0, shifted up 1, so now we're at y equals 1. Then the y-intercept, which I didn't do it perfectly there, but we'll just kind of fill it in. The y-intercept is also going to shift up 1. So it's going to go from -1 to 0. So the y-intercept will be at 0, 0, which we're not asked to find, but it is helpful when you graph to find the intercepts. And of course, if the y-intercept is 0, 0, there's also an x-intercept at that same point. So now, so here's our graph. We have our horizontal asymptote there at 1. And so we have not done any horizontal shifts, which actually would not matter with a domain of all real numbers. The domain will still be all real numbers, no matter how you shift this. But the range, of course, is going to change. So the range, just usually a good idea, probably just to visually confirm this. The range is going to go from, so you start at the bottom. I always start at the bottom when you're finding the range. So we don't go left to right. If you're looking for the domain, typically you figure that out left to right. And then if you're looking at the range, typically you find that by going from the bottom to the top. So the bottom, this is going could go down to negative infinity. And then it's only going to go up to your horizontal asymptote, which is 1. And then, of course, it's not going to touch that. So we're going to have a parentheses there. So just to kind of recap, you go through, it's typically easier when you have multiple shifts, multiple transformations to do these one at a time and kind of draw the graph for each one. That's typically the way I would like to do it. So if we go from here to here, this is a reflection around the x-axis, and that is for the negative. Then we go from here to here. That is going to be a vertical shift up 1. So the order is important. You got to do the horizontal, the reflections, and then stretches, and then the vertical. So vertical always comes last is really the important part to remember. But that's really it for that one. If you have any comments or questions or any other problems that you want me to do, leave them in the comments.